Alright guys, how are you? Good. Alright, so today what I want to do is first off take any questions from homework. We're going to lecture just a tiny bit, and then as promised last time, I don't know if you remember, finally going to shut my mouth, stop talking all the time, and let you guys do some stuff. Wednesday I'm going to give you a practice quiz. I don't normally do that, but this next quiz, like a double quiz, ooh. So I'll give you a practice quiz on Monday. We'll look it over. I'll give you an answer key, and then next Wednesday after that is the practice is the quiz. It's a double quiz on probability. So any questions from homework stuff? The double quiz? So one reason why it's called a double quiz is it's twice as long and it's worth twice as much.
Okay.
Yeah. So there's two reasons. That works out pretty well. Two reasons for the double, yeah.
Cover all of chapter 4.
Yep, all of chapter 4. Yep. Any questions on homework?
Yes.
Yes. That's fine. They don't say anything.
For the numbers of the question, that's so confusing. Just like the EOP, EO, that's so confusing.
How is it confusing?
Because sometimes there's the pairs. We have 6, 9, 12, but the simplest is the question on the other exercise.
Duty, I'm sorry?
It doesn't connect.
Sure.
I'm doing the section 4.4 right now. For example, you give the and it's like each trio, right?
Okay.
Each other
Every other.
trio. So
There, okay.
and I'm at the number. Okay, look right here. It's like 6. 9,
6 through 9? No. Wait.
12, but then the
No,
12
no,
it's another one.
Alright.
Oh no, I mean like the every third one.
Okay.
It's like this 12, but then after the 12, it goes but far in the new one.
What's the matter?
Because like after that it's 15.
Okay, sure. So what's confusing about it?
Because we just end this part and we go like down like in the other part, but without doing the first one.
Okay, that's fine. This does not depend on these. The results for this one doesn't depend on these.
Yeah, but I don't know, it doesn't make sense.
You could do more if you want to. If you do want to do that one, you can.
No, because every time it's confusing, so every time I'm doing one and then I do the other one.
All right. Come see me later, I guess. I can't make, multiples of 3. I'm not sure how to make that easier. It's okay that it goes into, they got a sequence of problems that relate to a table or something. And maybe one table is for 13, 14, 15, 16. And then I ask you to do every third one, so you just do number 15. Okay, so you go to the table and you do the work. It doesn't depend on number 12 and on number 13, number 14. Right? I mean, all right. Please don't let that be the problem. I mean, that's
No, and
yeah.
can you explain the other one? Each other one? So you
Yeah. So, all right.
because the one before.
No.
feel like the teacher, you know? Like, to me, if you're doing the homework, take page. Oh.
No, what are you talking about?
Okay, so the pairs. Here. That's confusing because we start at 6, right?
Sure.
So that means we do 6, 7.
All right, guys. All right, I got you.
It's fine.
All right, so every other pair. Every other pair? It's the 6th week, by the way. We're getting into the 6th week. So we should be used to this stuff for homework, or else that's a bad sign. Every other pair, I explain it on the homework sheet. You know, it's to me, it was just the quickest way to get a large amount of homework assignments. I hate giving like these long-ass homework assignments, 1, 3, 5, 9, 10, 11. I hate that shit. So this, I had to do this sometimes with the way that the problems are, so you see every kind of problem that they have in the book. So what's every other pair mean? So you start at 6, so you do the pair of 6 and 7, and then you don't do 8 and 9. And then you do 10, 11, and then you don't do 12 and 13. That's what it is. Yeah. There's an example at the top of the homework sheet. I don't know if that's the problem. That's a prerequisite almost for being in college. All right. Sorry. Is there anything else from homework? I like it. So I don't know if this has happened yet, but very often there will be things I purposefully,
Because you might have random everywhere.
guys, very often there will be things I purposefully leave out because, you know, there's a reason you have a textbook. You're supposed to read it. So you hit something in the homework that you haven't heard about before, you can ask me in class like you just did, but you can also, you know, look through the section real quick and see if they talk about it. Subjective probability would be if I ask you, what's the probability that tomorrow morning you wake up late? Right? For some of us, you'll be like, 98%. You're talking about the way my life is. Right? For some of us, it's like 0%, man. I am always on time. Just, that's subjective. It's kind of based on your own experiences. Did I actually calculate it? Did I really sit down and analyze my... No. It's based on our feelings. It's based on our... Yeah. What's the probability that you'll be bitten by a shark? You know, you. Then you'll be like, well, I never go in the water, so unless there's land sharks like on the old Saturday Night Live skits, knock, knock, don't answer the door. Girl Scout cookies. It's a land shark. That's going way back. But they're on YouTube. Look it up. Is that cool? So subjective, we obviously aren't going to talk about it a lot in a math class, but they exist. So which question are you talking about? Is there a question you're talking about? Or?
Estimate the probability the next time you're riding a car you'll get delayed.
Okay.
It's kind of like, well, it depends. If someone that lives 15 minutes from here is not going to be as likely as me that lives an hour away.
Okay, so how's that a problem? So your answer will be different from...
The answer is going to depend on
That's the idea of subjective, right? That's what subjective means. So maybe online dictionary, right? I mean, subjective mean, objective, subjective.
I know what you mean by subjective. I'm just worried about if I put it, somehow I've got to show you how I get what I get. And
Give me a little bit of an idea. You could say, it hardly ever happens to me, so like 1%, or happens to me like every other day, so 50%. Give me a little bit of an idea, but you don't have to go in this huge story. Well, when I was younger, and I lived, no. Does that make sense?
yeah.
So that's a good question. I don't want to have it, and feel free to ask if you hit something in the homework. There are certain homework problems that if I never get questions on them, I'm very worried, because I know either they're really weird or I didn't even talk about it on purpose, right? So that's one of them. So I'm glad you asked it. Okay, cool. All right. Anything else from homework or about homework? Yes?
Wait, Jason put 4 to 4 points, we put 4 and 4 points against Tuesday, right?
It's not due.
Oh, no. Chapter 4 homework will be due on the day of the quiz.
Okay.
Section 3-4 homework will be due by the day of the next test. You guys hear me? Because section 3-4, the box plot stuff, that'll be on the next test. This quiz coming up will only cover probability. I want it to be purely about chapter 4. So then homework for chapter 4 will be due on the 11th. Right, just like it on the quiz day on your homework sheet. Is that cool?
Yeah.
Okay.
So chapter 3's homework hasn't been due yet?
Section 3.4
Yeah.
was not due.
Oh, okay.
Yeah, I just said you should do the ones that dealt with Z-scores.
Yeah.
In case I wanted to put some of that on there. I ended up not putting much on there.
So it's not actually due until the test?
Section 3.4 is not due until test 2. Yeah. Cool. Anything else from homework stuff? Okay. All right. So here's what I'm going to do. I want to. There's a couple little things I want to fill in from chapter 4, and then I got this little handout for you guys to work on. I'm just going to run around the room and help you guys out. There's some definitions I want to fill in real quick, and there's a certain situation that I want to talk about. Let's talk about the situation first. 11% of Americans are left-handed. That's the last trustworthy source that I've seen was 11%. I don't know if that number's changed, to be honest. How many of you guys are left-handed? Anybody left-handed? One. Okay, so one out of... So we're a little bit below the expected value, right? I'd expect to have about that much. So if I... Now, how many people is that out of? 11% of how many people?
100%.
Does anybody have any idea how many people I'm talking about up here?
3.5 billion.
Wow!
Or million.
Holy crap! Now I know McDonald's has served billions, but there's only 320 million or so, I think, right now in America. 320 million Americans. You guys kind of with me here? So here's what I'm talking about, though. Here's the idea I'm talking about. When we had a deck of cards, and let's say I pick 3 cards, and what's the probability I get 3 kings if I do it without replacements? This is a nice little review of what we did last time. All right, so this kind of problem should sound familiar, unless you weren't here last time. You're like, what the hell? So those probably get 3 kings. Right? Who was it? George Clooney? Who else? What's probably the first one's a king?
1 out of 52. Or 4 out of 52.
4 out of 52, right? I got 52 chances, 52 things I could pick, and I want 4 of them. And then I throw that one away, right? Feed it to my little brother. And then what's the next one's probability? 3 out of 51. Why did those numbers change?
It's not related.
Because the numbers change from one to the other, right? Once I picked the first one, I threw it away. I did it without replacement. I don't know if you guys see where I'm going with this. And of course, what's the last one? 2 out of 50. Cool, right? Now there's even one less king, one less card. 4 divided by 52. What is that? Somebody help me out. What's that by itself? What percentage is that? True.
7.6.
It's good, about 7%. And of course, 2 out of 50 is 4%. So it makes sense that the more kings I'm throwing away, the harder it is to get another king. Are you guys kind of with me? Right? So if you've got 2 kings and you're trying to win a poker hand and you see 2 kings on the table, you got 0% chance of getting another king. They're all gone, right? I don't care how good of a friend you are with the dealer. All right. So whatever the hell that is, if you multiply that all together.
0.02%.
Who is it?
0.02%.
0.02%. I like so 0.00002. Something like that? Sure? Okay. Now stay with me. I really want you to stay with me, because this is where people make weird mistakes. What do you think I could do here? What about this situation? If I said I pick 3 Americans randomly. I pick 3 Americans. What's the probability that they're all left-handed? What can you do? Do you see how it's exactly the same problem as this, except for one major difference? Yeah.
Wouldn't it just be like 11 over 100 continued with replacement, basically, right? Like you would have 11 over 100 still?
Yeah, why? You could do that totally, because the mistake I see, now be careful, this is a total mistake. I really want you guys with me. This is a mistake, and you should be able to tell really quickly why this is a mistake. Somebody always tells me this. And then, of course, my dorky thing I write on the paper is, so there's only 100 Americans. What the hell? So then, on corrections, they go 11 out of 320 million, which, of course, is not good either, because it's supposed to be 11%. What is 11% of 320 million? Stick with me for a second. Somebody help me out. Yeah, 3, 2, 3, 5. 11% of 320 million. So I think it's 352. That right? 35,000. 35 million. Yeah. Okay.
There you go. I know math.
So I mean, no, I really want you guys to be with me here. That's a rather large population, right? And how many people am I picking out of that population? How many people? 3, right? And actually, I'm not picking out of this. I'm picking that out of 320 million.
Yeah.
So I'm only taking 3 out of 320 million. Taking a very small sample of America, right? So that kind of plays into this. Now watch. If I did this by the book, I'd have to do that out of 320 million times over 319, 999, 999, 35, 199, 99. Do you guys see how that would be doing this? But dear God, no, hell no. Because is that really that different from this? Hell no. So mathematically, these are very close to being the same thing. So when you have a large population, in fact, let's make this very specific. This is called the 5% rule. If the sample you're picking is less than 5% of your population, you can just go ahead and not do this weird shit. So there's a 5% rule. I forget what page it's on. There it is. Page 158, at the top of page 158. If your sample is less than 5% of your population, then you can treat them as independent. You can treat them as with replacement. So how would I do 3 Americans, all of them left-handed? What's probably the first one's left-handed? What's probably the first one's left-handed? 11%. And times the next one's left-handed, 11%. Times 11%. Of course, what's a nice way to do that mathematically? Yeah, that's beautiful. 3 of these people. That's what I want. I want 3 of those people. This one I had to do, because how many cards am I picking here? 3. And what's 3 divided by 52? Yeah, so it's more than 5%. So I had to do this. Plus, it's not very difficult to do this for the small numbers. Are you with me? So even 2 cards I could still do this for, because this is easy. But for that, do you want to do this? Thank God that rule says you don't have to. Mathematically, it's close enough to just assume that they don't change. Just assume you're doing it with replacement so that they don't change. How are we doing so far? Is that decent?
So you
So-
just cube it, you're saying?
Yeah, so that would be 0.11 cubed, which is, let's see if I can do this right, 0.001331. Anybody do that?
Yeah.
Ha. Sorry. I just did that in my head. No. So let me show you one more example with this, and then I'll do my promise shutting up. Yes?
Okay, so if it's more than 5% of the first probability, then it's...
No. If the sample you're picking, so in each of these cases, the one I had here just a second ago and there, my sample is 3. 3 Americans there, 3 cards here. But this was out of a population of 52. That's more than 5%. I can't do the shortcut rule. This was out of a population of 320 million. 3 out of 320 million is way less than 5%, right? So I'm completely allowed to pretend like they don't change. Because they basically don't. Maybe in the 9th decimal place. But we're humans. That's basically not changing. Yes, sir?
So you're saying it's 0.13% chance that they're all left-handed?
So you're saying there's a chance. Sorry. Yeah, 0.1331% chance. So if you pick randomly 3 Americans, just randomly from all of America, you'll have a 0.1331% chance that they'll all be left-handed. You guys with me? Now in this room we have a 0% chance because we got one of us. Right? So once I pick more than one person, there's a 0% chance they're all left-handed. Or at least telling me that they're left-handed. So let's do one more of these. What's the probability that I get the first one is lefty and the last 2 righty? And again, I have to be very specific so that the math doesn't get too crazy. Yes?
Just 11 over 100, 89 over 100, 89 over 100.
No, well, do it again. I'm sorry?
Yeah, 11 over 100.
No, okay,
Yeah,
gotcha. I
89
didn't hear you.
89.
So what's the first probability? The first was left-handed?
11%.
11%?
89%.
Yeah. To be right-handed, what's the probability that you're right-handed?
89%.
And we're assuming that we're either left or right. You got to pick one. You with it? Ambidextrous people, that's nice, but let's say you got to pick one. Pick the one you like better. Whatever your reasoning is. And if you look at it, it's kind of cool. 0.11 to the first times 0.89 squared. 2 of these, 1 of these. The exponents really make a lot of sense. They always do, but here they have an extra added meaning. And then whatever the hell that is. 8.7%? All right, so of course you have a much higher probability of this because there's a lot more right-handed people. All right. So if you want to, when I give you this worksheet, number 3 is a problem exactly like what we just did. You could do that one first.
Is that the same as if I said what's the probability of getting like a left-hander and then a right-hander and then a left-hander? Is that the same?
No, because then the left-hander back here would be 11.
Oh, yeah, but would it be the same if I said a right and then a left and then a right? It's the same probability of doing
Exactly. If I said right and then a left and then a right, this would just be, and math would say it's the same thing. So watch, if I said, what's the probability to get exactly one left-handed person? How much work is involved? I don't know if you remember this, what we did with the clocks. If I said, what's the probability I get exactly one left-hander? And we're going to leave this kind of problem until chapter 5 because we're going to get a much quicker, nicer way to do this. But probably exactly one lefty. Who could be left-handed? The first guy and the last 2 are right-handed like we did here. Or the first guy is right and the middle guy is left-handed. Or the first 2 are right-handed and the last guy is left-handed. So right now I'm going to be very specific about the order. I'm going to say the first guy is doing this and the other guys are doing this. I've got to be very specific or else, you know, the minute I say 2, this list could get huge. Right? Like the pizza toppings thing. Right? The list could get really big. Yes?
For that equation you just did there, is that exactly 1 out of the 3 that are picked?
Exactly, 11. So this whole thing is about picking 3 Americans. Yeah. Good. I like it. If I picked 5, this would be like left, right, 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 and so forth. Okay. Maybe. All right. I desperately want to let you guys do this. Here we go. So number 3, like I said, is just like that last problem. This is not a quiz, so you guys can work together. You can call me over if you need some help.
You're the expert, right?
Yeah.
Oh, all right. Oh, good. You guys sitting in. What's the probability? Well, this is, let's see, 8.
7, 11,